This video is brought to you by StarCharge, the largest EV charging manufacturer in the world. They are also a provider of residential and commercial battery storage with microgrid solutions. Hello and welcome to another Out of Spec Reviews video, and welcome to a full tour of Volvo's electric stuff. We're not talking the cars, which of course we're all familiar with. Volvo EC40 it's been renamed to, Jordan, and then there's also the EX40, the EX90, the EX30. We all know those vehicles. This is the other side of Volvo, the other divisions, which are sort of heavy duty. So we're going to be talking Volvo VNR Electric, the truck, which is sick, but also some construction equipment that they have as part of another division within Volvo. There's more that the company is doing across all sectors as well. But in this video, we're actually going to really dive into the Volvo VNR Electric, which is one of the most popular electric trucks in the US right now. Hundreds of these, maybe thousands, we'll have to ask, are already out on the roads being driven. I've seen them at like Port of Long Beach and other places, and I've always been so curious to check them out, learn about the charging, learning about the voltage range of the truck, all the nerd stuff. This is the powertrain for it. It's a dual motor, but coming basically out of there's like a little drive shaft that comes where they combine the power of both motors. Some really interesting, weird things when it comes to trucks. So join me as we learn about Volvo's electric truck and some of their construction equipment here in this video. Guys, I am learning about electric trucks this week. It's pretty interesting. This is an industry that's pretty reluctant to change, pretty, a bit like Harley Davidson owner, someone just said to me, it's like you change anything and everyone freaks out. So the idea of an electric truck for many people is like, holy smokes. From us, from the EV perspective, it's like, hell yeah, why wouldn't you make a truck electric? It's running 24/7, it's gonna be more reliable, it's gonna have more power, but then the weight goes up and the costs go up massively. Just to give you an impression on the Volvo VNR, I just spoke to a dealer. They're roughly $180,000 for a combustion one, and then like close to $500,000 for the electric one. But that is, of course, there are plenty of incentives out there and there's reasons as to why you need to go electric, but the electric trucking and heavy duty space feels like electric cars 15 years ago. Very expensive, still very compromised in terms of range and charging performance and infrastructure, and it's just the tip of the iceberg. We're seeing really cool vehicles come out like Tesla Semi. Of course, I cannot wait to check that one out. That actually seems to be maybe the first product that makes sense for long distance use that I've seen. But these VNRs are hugely popular. A dealer I just spoke to just sold 40 of them to a customer. Huge money. We're not messing around. These are a thing. They're in the market. So let's at least take a look at the truck. Jordan, there's 2 battery packs on offer. We can actually show everyone the situations right here. So you have 5 different styles of configuration, from high roof to low roof, single axle in the rear, dual axle in the rear, different axles that can be powered. And so they have a 4 and a 6 module battery pack, and you can go all the way up to the maximum 82,000 pounds gross combined weight, and that is the maximum the road allows for an EV. EV can go a little bit higher because of being an electric car. They give you a bit more weight rating on the road, and up to 460 kilowatt hours usable, plus or minus.
Something like that, yeah.
Yeah, and then there's a small battery that's like 300 and a bit kilowatt hours. But here's the hood open on this one. This is the VNR. This is meant to be a day use truck. This is not a long distance, long haul, of course. Those applications will be coming. Volvo's doing a lot of work on their combustion trucks actually to make them significantly more efficient. We may have a video coming to you guys soon about some of their updated stuff. I'm looking forward to that. But look under here, no massive diesel engine. And the thing that's interesting is there's 2 schools of thought when it comes to electric trucks, similar to electric cars 10 or 15 years ago. You can go for a bespoke, ground-up battery electric platform, which in this industry sounds like it might freak some people out, might be really cool and lead to longer distance capabilities and more unique advantages. Or you can take a combustion truck, put an electric drivetrain in it. The chassis is already durability cycled to run forever and on and on. And so this is the approach Volvo took with the VNR. They needed to get an EV truck to market. They converted their existing combustion one, and well, here we are. I've never really even sat in a truck before. Jordan, have you? Maybe I have just once before,
yeah,
actually.
we have a couple times, but...
Oh, yeah, that's true. What am I thinking? We did the Nikola.
Yeah, we did electric. A burnout in electric truck.
Yeah, that's
not
right.
Electric, hydrogen, I guess, in that case. But yeah.
Was it a hydrogen one or a battery one?
That was hydrogen, I think.
Okay,
Yeah,
but you can take a look inside. We'll jump in the cab in a little bit, but really cool instrument cluster. It all kind of looks the same as the standard combustion one that you would expect.
Looks like the 90s in there.
Yeah, that's right. Trucks are very lagging behind the car industry. Weight distribution, of course, is something that's interesting when it comes to electric trucks. You're going to have the majority of your weight here in the battery packs. And so this one, I'm assuming, is the big battery 6-module one. This is actually owned by 4Gen, which I think is one of their customers that's on display. This isn't like a press truck or anything like that. But I'm trying to see, yeah, so they, interestingly, rather than having the motor on the axle, run a drive shaft on this. So it really feels like it's a combustion truck adapted to electric. So when we talk to the engineer on this truck, I want to be like, why did you do that? Why wouldn't you build a ground up? To me, we just listened to a presentation by Dan Priestley, who runs the Tesla Semi program, and not to be like Mr. Tesla over here all the time, but like, he made a good point. He made a call to action to the industry to say, don't build conversion trucks, build ground up EVs with proper infrastructure, with proper powertrains, with long distance capability, with integrated thermal systems, and make it a holistic package.
And I think we'll get there because with semi trucks, especially the combustion ones, they're like eking out every half mpg. They really care about that.
Yeah. If you go from 10 to 10.2 mpg, that's like almost worth it to upgrade to the new truck. It's going to be really interesting to talk to the Volvo guys about this particular one and the strategy and what they think the future of the industry will look like. We're just breaking into this world. It's something that's happening. We want to cover it here on this channel. But from the outside looking in, it's like you're never going to make back your money on this. This is $500,000, Jordan.
Yep.
That's crazy.
That's where incentives, hopefully come into play.
Right, and there's huge tax incentives, especially in California, and then there's local, municipality things, but like, that's a lot of tax dollars going to subsidize these things.
Yeah.
I don't love that. Of course, there's a lot going to the oil industry and everything. We don't need to get into that topic on this show, but it's like, when will this make sense without government incentives? At what point is it actually cheaper to own and operate an electric truck? I think we're still pretty far away from that using this business model. Tesla Semi seems closer, but again, I don't know what they're actually retailing for. I know they said $250,000, but that was years ago, Jordan. So we don't actually know.
7 years ago when they first unveiled it.
Yeah, so they might be more money. I don't think they've disclosed what they're paying for them yet. So anyway, let's go talk to the guys here, learn about the truck, learn about the use case, learn about the technicals. I wanted to figure out that dual motor system. That's kind of interesting. And that'll be a fun video, us breaking into the world of electric trucks, which we've already done that Nikola video, but here's the whole
new, there's like 20 models here. It's crazy.
I mean, it's like we got a lot of catch-up work to do. So let's do it. Guys, you joined me with John. John is responsible for electric vehicle strategy at Volvo. Can you explain maybe your job title a little bit better than I could?
Of course. I'm the Volvo product manager for electric vehicles. So basically I work with strategy for future vehicles. I also work with today's vehicles as the VNR Electric here. So somewhere caught between engineering and customers.
Perfect for our audience. Yep. That's amazing. So, of course, we have all the nerd viewers, but we come from the vehicle side. We're just breaking into trucks. Of course, Volvo is one of the leaders in trucks. I see them on the road all the time, both in Europe and here in the U.S. These are built in the U.S., right?
They are. New River Valley, Virginia.
Yeah, very cool. So, why make an electric truck? Everyone's kind of breaking into the space right now. You have one of the more popular electric trucks on the market with how many hundreds are out there? It's got to be a bunch.
Oh yeah, right now we're over 600 trucks out there. We've logged over 5 million miles hauling freight.
Oh, no way. Okay.
So yeah, some of our bigger customers are the ports of Los Angeles and Long Beach. So ports and drayage operations, these are working really well.
Yeah. And those are pretty rough applications because it's low speed, high torque, ripping in and out of places. What's the reliability been like?
Actually, it's perfect for this truck because it is low speed, a lot of stop time waiting. It actually causes issues with diesel trucks because of the after treatment systems tend to plug up sometimes. So really short distances, sitting a while are really conducive for electric vehicles.
So help me wrap my head around the cost proposition. This is, 2.5 times the cost, plus or minus, of a combustion truck. You've already sold hundreds of them. Where's the benefit for these people buying and spending that much money on it? Are there tax incentives? How do you make this an attractive buy?
Well, I mean, to make it a good business case, you have to have incentives. So obviously California, they have a program in place, HVIP, to where they will incentivize these trucks and really get the cost down low enough or close enough to a diesel vehicle where it makes sense for customers to try it. And not only California, New York is doing it. There's several states now with incentives packages that make this help. Now, the whole idea is to be scalable. So the incentives we know will not be there forever, but as economies of scale come into play, as we sell more vehicles, we'll be able to get the prices to come down.
Okay. Yeah.
And most of the cost of the truck, I say most, half I would say, are batteries.
Wow. So the batteries, of course, are always going to be the biggest cost driver here. At what point will you think that it will be possible to make it because a lot of fleets aren't buying it based off an emotional decision, like this is a cooler truck or it's nicer to drive. It's what is the cost per mile over the life of the vehicle. How many years away are we, do you think, from an EV being the clear choice?
Oh, I mean, I would say sooner than later.
Okay.
I can't give dates, but I would say when battery technology gets more efficient, that's where we need to be. We need more range out of the vehicles. There's two schools of thought here. Mm-hmm. To me, to get something hauling 80,000 pounds to go 200 miles on batteries is phenomenal. But for our customers, they need to go further in many cases.
Okay. Yeah.
So for this to be scalable, we have to have more public infrastructure to charge, better battery technology to get more range.
Yeah.
But that's what we're working on. We have many projects out there we're working on for future trucks that we're going to get more miles and more miles as we go along.
I love to hear it. That's music to my ears. It's exciting. It's like watching electric cars 15 years ago is how we kind of opened the video. It's like, this is definitely going to happen. The question is how, when all of these things can, will change, but the end goal is clear. We will have, cleaner powered trucks. And Volvo is really, especially in our market, going hardcore in electric, not so much the hydrogen sense. I know in Europe they're working on some of that. What's your impression of the battery electric being the fuel source for trucks?
I think battery electric is perfect for distribution cycles, regional haul cycles, things where you're, if you're 400 miles or less, let's say.
Okay.
The problem with battery electric for long haul, and we're a long haul company, I would say 70% of the trucks we sell go across the country, and they're literally being driven, 10, 11 hours a day.
Yeah.
So right now, electric cannot handle that application.
Of course, yeah.
And we don't see it handling that application really anytime soon in the future.
Really? Okay. And public infrastructure, of course, is a key enabler to that. And we've just started to see the first megawatt sites go in. Jordan was at Watt EV charging hub in Bakersfield. That's like the first of its kind where trucks can roll up. But I still think you need a membership to use that or something. I'm not sure. But let's talk about the truck.
Oh, so, back to your hydrogen question.
Yes.
That was my lead-in for that question.
Okay, yeah.
We do see hydrogen in the future as something that bridges that technology or takes us to a long-haul vehicle.
Okay.
Whether it be hydrogen ice or fuel cell. So
that's right, because you can do combustion hydrogen, and our office where we actually work out of, they're doing a lot of research on those topics. So we're around that every day. It's really, really interesting. And I think we have a split audience on that. A lot of our audience is like, okay, well, we just want to see battery electric everything and use LFP batteries and rip with that. And then I would say the other half of our audience is like, there's no clear one technological solution, at least in the short term, to make this all work.
Oh, believe me, we would love it if there were. Because we're investing in multiple directions, even with diesels. Clean diesel, passing these new regulations coming out, it's challenging.
Okay,
to do everything at one time.
You're just talking a lot of weight, a lot of aero. You need a lot of energy on board, and diesel's easy to haul at the moment.
Well, it's been around forever, right?
Yeah.
So it's established. And, out of the bat, everybody wants this to do exactly what that does. And we know that's not going to happen anytime soon within the next few years.
Yeah, but
it takes time.
Probably enough applications for this to fill the production capacity for a while.
Exactly.
So walk us through the truck. It's a VNR. VNL is the long distance big boy.
Yeah, the VNL basically has a longer hood, but it's what we call a long haul vehicle. The VNR is a regional haul vehicle with the shorter hood. So this one's got a 113-inch BBC, bumper to back of cab, whereas the VNL will have about 123-inch BBC. Mm-hmm. So what it does is it just gives you better visibility in the city. So just imagine driving something this big in the city, delivering goods. Visibility is key. So if you sit in the seat, you can see all around the truck. And this short hood also gives us a shorter wheelbase along with it. And we have a 50-degree turning cut with this truck. So it'll actually have a turning radius of around 30 feet.
Oh, wow. What the
Which,
heck? That's better than the Silverado EV. That's better than the Cybertruck. Yeah, that's amazing.
Well, remember, this is a radius, not a diameter.
Oh, okay, okay.
Yeah.
Ignore what we just said. Okay, so help me understand how everything is being powered. So you have the steer axle, which is just passive.
Yeah, the steer axle's passive, so everything's powered through our EDU drive line. So in this vehicle, we actually have a drive shaft going back to the tandem axles.
And is that the most efficient way, or was that just because you're working with an existing platform to convert?
We wanted the switch to be seamless to our customers.
Okay.
So the VNR is their favorite truck for regional applications. So why not put an electric drive line in a VNR, something they're already used to? Mm-hmm. So we put the drive line in just to make it simpler at first for us to get it out in the field, not have any issues with it.
This is Gen 1 electric truck for you guys, more or less.
This was the first prototype. This is actually a Gen 2.
Okay.
We have two phases. The phase 1 came out in 2019. We started selling in 2020, and then we upgraded to the phase 2. So really the biggest difference between the phase 1 and the phase 2 is the generation of the batteries. We went from a Gen 2 battery to a Gen 3 Akasol battery, which gave us more energy on board.
Right.
So the first one had, I think, 66 kilowatt hours per battery pack, and this one has 94.
And you can do a 4 or 6 module configuration in this one.
Yeah, we have many different models. So the most popular version, 6x2 or a 6x4, meaning 1 driven axle or 2 driven axles. In this vehicle, that's the most popular. We also do a single axle with a 4 battery pack.
Oh, so that's like that's the base one, more or less.
Yeah, if you have a single axle, most people like the 4 battery pack there.
Yep.
And the straight trucks, we do 2 of those, and those have 4 battery packs.
So you're working with NMC chemistry, just under a megawatt hour worth of capacity on the big one. Talk to me about charging. Where do you even plug this thing in?
Right here.
Okay.
Good question. So we have the charging port right here.
Oh, dang, look at that. Just a regular CCS inlet.
There's a CCS 1. We went with CCS 1 because that's the most popular right now.
Yeah. Do you think you'll switch to NACS?
We will go with whatever the industry does.
So MCS probably.
Yeah.
High power.
MCS, what we'll do is we know you'll have, in the future, we'll have something with MCS, and possibly we know we'll have other people with slower charging CCS1. We'll have to be ready to do both of them.
Do you even have AC charging capability?
We don't do AC charging because
DC only.
picture a water hose filling up a swimming pool. It would take 2 weeks to fill these batteries with AC charging.
Yeah, but a 50 kilowatt is like a level 2 overnight charge for this thing.
Yeah.
What are most of your customers charging these things with? Are they going full power? Because it'll do 250 kilowatts maximum, right? So are they all putting in 300 plus kilowatt chargers, or are they putting in 24 kilowatt or 50? Or
That's an excellent question. And when we first started doing this, we thought, well, everybody's going to want a smaller charger.
Yeah.
Try the 50 kilowatt, you'll get in at a lower price. And they're like, wait a minute, what are you doing that for? We'd rather just pay the money now.
Wow, really?
Get the bigger charger and be able to charge fast enough to get our operations done properly.
So they're ripping high-speed charging on these things all the time.
Most are going with like 100 kilowatt.
Okay.
Or they'll go with 150 and split it 2 ways for 75 and charge 2 trucks at once.
Makes sense.
The phase 2 truck went up to 250 kilowatts, like you just mentioned.
Yeah.
So now people are looking at 250 kilowatt.
Just talking to some customers around the booth and stuff who own multiple different brands of electric trucks. I know you can't comment on them, but they said this might be one of the best charging electric trucks that they've had. It's not as efficient as some of the other ones, but they're like the charging speed is so much better than we've seen other vehicles. Like, at least I can say, I know the Freightliner, the Daimler stuff, they have 2 CCS inlets because they're low voltage. This is pretty high voltage. You're like 700 volts on this, right?
We run 600 to 800 volts.
Nice.
So we can push in twice as much as a 400 volt system.
Yeah, so that's where the real charging performance comes with the single port, which is nice, and less losses than, of course, doing
and that's the key.
Voltage.
Yeah, it's less losses, so it takes a lot of design work to make sure you don't have the losses. I mean, you're talking about a bunch of amperage going in.
Yeah, of course.
So
how do the brakes work? You have hydraulic systems, you have power steering, you have brakes that are air brakes. You have an electric air compressor, I imagine. Is that a high voltage air compressor?
It is, and it's a good point you brought that up because we're right here at the part of the truck that has the air compressor. right under the steps, we have a 600-volt air compressor. So that supplies air to the entire system. So air for the cab, air for the air ride seats, air for the brakes. All of that's driven by this one compressor.
And so this doesn't need a DC to DC. It runs right off battery pack native voltage.
This one runs off native voltage, but we also have many other components that have the DC to DC converters.
Yeah, what needs to be stepped down? What is still left to come?
Well, we have 2 air conditioning compressors, or AC refrigerant compressors under the hood.
Yeah.
And those are 24-volt compressors.
Oh, wow. Okay. So you really got to step those down. But
Yeah.
as supplier base catches up to electric trucks, I imagine those components can be 800 volt rated, and then you can start using, less losses, less DC to DC, and more native voltage
Of course,
components.
yes. Obviously, the higher the voltage, the more efficient it is. So on our trucks in the future, who knows? We might have 600-volt compressors, 600-volt
Yeah.
fans. I mean,
What are you noticing from the supply base? Because of course you work with a bunch of suppliers to assemble the vehicles in Virginia. Are they even thinking about electric yet, or are you really pioneering this EV truck space?
well, I mean, they are thinking about electric, and we try to do this with our European operations. We work together very closely with certain parts to try to have scalable parts for customers to invest in this.
Yeah, okay. Good to hear. Weight distribution is something that comes to mind, of course. Traditional combustion trucks will have a big, heavy diesel over the front axle. How does that change? What's your impression? What are people thinking about having batteries in trucks?
Well, I mean, weight distribution wise, we have this pack right behind the cab.
Oh, so this is a battery pack here
Yeah,
then.
these are 2 extra packs in this gantry, we call it.
Okay.
And on top is our battery thermal management system. So when we went with the batteries that had 94 kilowatt hours each in them, we had to cool them. Before we used ambient cooling.
Yeah,
And
so
we-
now you're doing glycol liquid cooling.
Yeah, so this one actually has its own compressor, AC system to cool them quickly.
Do you have a heating system in the wintertime as well to heat the batteries?
The batteries have to keep themselves warm.
Yeah, so you'll precondition before charging and other stuff like that?
If they're on a charger, yes, we can turn it all on and get it warm before they take off.
Oh, okay, cool, very nice. But if you're just driving and it's really cold and you're about to go stop for a charging stop, is there a way to warm the batteries
They will
before
be
you charge
warm
from the usage?
from the usage.
Okay,
So
makes sense.
it's okay if you're driving and stopping.
Yeah, and again, 250 kilowatts on a half a megawatt hour system is very low power for the cells. It's not like an EV where you're stressing multiple C on those cells, and they really need to be at the optimal temperature.
Exactly.
I imagine this just, no matter the conditions, will just pull full power.
Well, actually, when you do charge it, you'll hear the pumps come on. We will actually cool the batteries while they're charging all
Nice.
the time.
Yeah.
Just to make sure they're not overheating due to the charge.
How much power do these things make?
Power
As a torque to the wheels?
Oh,
or
torque,
yeah,
yes. Well, 4,050 foot-pounds of torque to the back of the transmission.
yeah. Okay.
And the horsepower off the motors is 450 horse.
Yeah. And
Or
it's,
should be 455.
sure, but the gear ratios are interesting. Maybe we should actually, can you show us where the electric motor is mounted? And then I want to go to the stand to show
Yeah,
everyone.
the electric motors are right down here mounted to the transmission.
Do you see a future where you'll do direct axle mounted motors?
Of course, yeah. We've already announced that in the future we're going to offer e-axles.
Okay, to me that just makes so much more sense than having a drive shaft running. But I get, so before we get to the motor, there's 2 schools of thoughts with trucks, just like cars. You take an existing platform, you electrify it, versus doing a ground up situation. And right now I think every Volvo electric truck we've seen has been a retrofit, if you will. It's been a combustion starting point. When will we see a ground up EV? Will we ever? What's the impression?
It's all about scalability. So right now, I mean, we're making a lot more diesels than we are electric vehicles.
Yes.
So it just makes sense for us to do it that way for now. But we're slowly changing it and changing pieces of it to where it is more electric.
Yeah, okay.
So you'll see more of that in the future. I
Yeah.
can't answer when,
Yeah,
but when you start to see the volumes take off, which we know they will in the future,
yeah.
then that's when the transformation will occur, that we start doing our own.
Out of all the trucking companies, all of the manufacturers of heavy duty trucks in our market, where does Volvo fall on the effort to electrify? Are you leading, pushing the industry along? Of course, Tesla's out here with their semi, but they haven't started really shipping in numbers. You have way more of these out there. Where do you fall into place, do you think?
Right now, I mean, we go back and forth. Sometimes we're the first in the market, sometimes we're second.
Oh, you're up there.
This month we might be first from the trucks we had delivered. Tesla is not delivering yet, as you mentioned, so we'll see where that goes in the future.
Yeah, just to Pepsi and a couple other, handful of trucks, something like that. So this is fascinating from the outside looking in. I can't imagine how exciting it is to be into it every day.
It really is. And back to your EDU comment,
yeah,
we do see a value there for vocational trucks.
Okay.
So, trucks that are hauling for municipalities. It might be little mini dump trucks or bucket trucks. So they have to have more ground clearance, and that's where these EDU drive lines come into play. You can have regular axles in the rear, and it works real well. So we may still offer both even in the future.
Sure. And you also are a drivetrain supplier for other applications as well, right?
Yes. You might have seen our drive line in the Tyco unit.
Yes, that's what I was thinking of.
Yeah, that's actually supplied by our Penta division.
Okay, but it's the one that was developed for this truck.
Yeah, it's basically the EPT 802 drive line you've seen out there.
Yeah.
With some modifications, and they'll take 2 of these batteries, I think, and stick it under the cab.
Yeah, and that's perfect because that thing's just doing low speed.
Yeah, just running around the factories.
Let's look at the motor. So the cab is identical to the combustion one.
Yes.
Just slightly different gauges, I imagine.
Yeah, the dash is different.
Yeah.
So we have the power meters in there. You'll have some differences in the stalks for regen control.
Oh, okay, nice. So you will regen to 0, or do you have to blend in friction brakes at some point?
Yeah, well, we start regenning at about 94%.
Okay.
Because, you have to do that just so it can go back into the batteries.
Of course, yeah.
And then we go all the way down, so.
Do you have a recommended daily charge limit for the batteries on these?
No,
so
recommended
everyone
charge
full
limit.
charges them then?
But, just keep in mind, if you run it continuously, batteries last based on throughput.
Yep.
So typically, this vehicle, the batteries will last 6 to 8 years.
Okay.
A normal operation that we see.
And it might even extend that if you're a little bit gentler on the batteries, if you're not 100% charging them every time.
Sure. Yeah. Personally, I don't think it would matter that much.
Okay.
It's real about amperage throughput, but that would make some difference.
Let's look at the motor, because this is juicy. We're normally used to seeing these little tiny car electric motors, and this is a heavy duty one that's got to take a lot of stress, a lot of thermal, stress as well.
Yeah, you have to haul literally 82,000 pounds with this transmission and these 2 motors.
Yeah, which is a lot smaller than a diesel combustion engine, of course.
It is much smaller. So yes, we got really heavy batteries, but we make up the difference with lighter motor and transmission.
Yeah. So what's going on here? These are 2 motors. You have an inverter on board, or is it an off-board inverter?
The inverters are off-board. So ahead of the motors, you'll have your inverters on the chassis in front of it.
Yep. So why 2 motors?
We use 2 motors primarily for startability. So these 2 motors, one of these motors in first gear will actually be at about a 9.0 to 1 ratio for better startability, and it'll run about 80% more RPM than this motor.
So almost double.
Yeah. So basically, when starting out, we're using one motor, part of another, and then as we go faster, near 20 miles per hour, we have a shift, so the synchronizer shift, and then we go to another speed, which will be second gear, and both of these then will be on about the same ratio. The RPM range on these, they'll run they typically get cruise speed around 7,000 RPM.
And what would you consider a cruise speed in terms of miles per hour?
On this truck, probably 60, 65 miles per hour.
Oh, they'll go that fast, so you could cruise down the highway in this thing.
We could make them go 75 miles an hour.
Let's make them go 90.
But the problem is, as big as that is, you can imagine the air resistance.
Yeah, efficiency goes
down, and then it doesn't go as far.
How many kilowatt hours per mile are they typically using? Because we're not talking miles per kilowatt hour. You're burning more than 1 kilowatt hour for every mile.
It just depends on the operation and how much weight and what terrain you're on, temperature. If you're driving in 20-degree weather, the air is much more dense.
Yep.
So therefore, you're using more energy. Yep. Plus, the cab has to stay warm.
Yeah, just like a car, it's same forces apply, but multiplied because you have so much more air resistance. So, can you give us a best and worst case range? Do you think?
We typically run from an efficiency standpoint. We can be 1.3 on our straight trucks.
Yep.
Up to 2.4 or even higher on some of the tractors hauling.
Yeah, if you're putting 80,000 pounds fully loaded, 2.5 kilowatt hour per mile, but that still gets you pretty good range on this thing.
Yeah, 200 miles typically
Yeah.
loaded is what you'll see.
Are you seeing
the 6 battery
customers?
pack.
Are customers asking for an even smaller battery?
Most people want as much range as they can get.
Really? Okay, so we're
because
still in that range
they're
anxiety
still
period.
not knowing what they're going to do with them. They want to use it on as many routes as they can. So yeah, they want maximum battery, but we have software that we use with customers to actually look at their routes, and then we tell them, okay, this is pretty much what the truck is going to use on the route.
Yeah.
And then they can make those decisions, at that point in time when they order the truck.
It is super cool. Well, I can't thank you enough for the tour on everything. I mean, you're in the EV trucking industry, so if you had to leave our viewers with one impression of where you think all of this is going to go, right now it seems very fragmented, not a clear, consistent message from across the brands, whereas, you compare a diesel truck to a diesel long-haul truck, and they're almost the same on paper. How far away are we from seeing this industry maturing?
I think if you look around you now, you'll see electric trucks on the highway, mainly in the cities.
Yep.
So when you see one, honk your horn or yell or say something,
Yeah.
because there's a lot of effort that went into making that happen.
Yeah.
They're super quiet. We have a lot of customers that want to show these in front of people. So they might be hauling flowers into a grocery store. So you'll see it start there.
Yeah,
But as
sort
we
of the
scale
high-end
up,
consumer market.
you'll see more and more on the highway.
Yeah.
So yeah, we're in for the long haul. We believe it. We want efficient vehicles and zero emission vehicles on the roads.
Yeah.
That's our image, so we're sticking with it. But bear with us. We still have to make diesel trucks.
Of course.
They're hauling America's freight every day.
Yeah, we can't just switch over. We literally don't have any high-power trucking infrastructure in our country. This is going to take some time.
Right. So if we're not doing it as fast as you think, don't think we're trying to greenwash or anything. It's just
Yeah.
a matter of we're trying to make it work as seamlessly as possible.
Well, I seriously can't thank you enough for the time and the information. I learned a ton. And we have to have you back on sometime soon.
That'd be great. Yeah,
I'm going to
so
come over to the factory in Virginia and learn with you guys a little bit more as well. So I'm looking forward to that. And this was eye-opening. Seriously, it was amazing.
Good.
Thank
Thanks,
you.
guys. Yep, absolutely.
I'm going to jump inside the truck really quick because we haven't done that yet. And I just think it was really cool how much we were able to learn about electric trucks, the industry as a whole. Really interesting. So we've got the grab handles, and here I am. Whoa, cool.
How do you feel?
I'm going to take the viewers up here and just show them around a little bit. So we have a kilowatt display, which is really cool. So you can show regen and power output. It's a 90-mile-an-hour speedometer, Jordan.
It's like my old Dodge Aries.
But yeah, it's pretty basic in here. Seems cool. Reverse neutral drive. Of course, your air brake situations for park. A little window out the back, but different configurations will be for everything. You've got a lane departure warning or a drift mode. I'm not sure which. You've got jellyfish shooting out of the truck over here as well. But how cool is this, dude? This is so sick.
Yeah, this thing would rip, you know it.
Yeah, absolutely. We really got to find a way to drive some of this stuff. And a huge thanks to Volvo for being so open about the truck.
They're just sharing it all, yeah, it's cool.
And what we're going to do next is we're going to go over to their construction department, and we're going to talk about their 750 kilowatt hour battery pack with DC charging built into it and all their construction equipment. So let's go talk to the folks over there. This was awesome. Well, guys, we've learned about the trucks. We're going to learn about a whole bunch of construction equipment, battery storage, a whole nother division within Volvo. We have Dr. Ray with us. Thanks for joining. And you're like the man. You kind of know so much about this whole, other side of the world that our audience never gets to see. Can you roughly walk us through, we're standing in front of a giant battery pack. What are we even going to see today?
So basically what we're doing is we're bringing in sustainable power to the off-road sector. So we build everything from 15, 20 horsepower small machines right up to multiple thousands of horsepower. And all of that has to be made more sustainable. Now, battery electric is not the solution for everything, but we're looking at hydrogen power, we're looking at hydrogen combustion, we're looking at alternative fuels, we're looking at hybrid machines, we're looking at grid connected. So any technology that we can make these more sustainable
Yeah.
for the future is something we're looking at.
The goal seems to be to reduce carbon with any technology available.
Decarbonize however we can, however much we can. That makes economic sense. It's still got to make sense for the customer
Totally.
to do it.
Yeah,
So,
we just learned the trucks are like 2.5 times the cost of a normal one with significantly less capability. So this is still early days in the trucking world. How would you say from the construction equipment side, from the off-road applications? I mean, you guys build some of the largest mining trucks. I mean, all the way down to, like you mentioned, small machines.
Yep.
How is this industry accepting electric, or is it even not even a thought for them yet?
So I talk about the 3 stages of acceptance that we have to get through to transform the industry. So the first one is you have to prove the machines will do everything that their diesel machine that we're replacing will do everything that can do. We've gotten over that hump. So any operator who gets on an electric machine, it's as powerful, it's as reactive as his diesel, but it's quiet, it doesn't vibrate, doesn't smell.
Yeah.
You know, you don't have the diesel all over you.
So it's like
They
when you
love
do
it.
your first electric car test drive, you're like, whoa, this thing is fast and really cool.
Yeah. And you're
Okay.
convinced.
So that's already happening.
So that's already happening, and it happened. The second step is we have to be able to charge it. We
Yeah.
don't have a luxury of working near roadsides or things where there are charging stations available. We use the same protocols to charge our machines, but we have to take the chargers off grid
Yeah.
and into remote areas. So this is one of the solutions that we've come up with for that.
Okay.
And the third part of it is where it gets really exciting, is when the customers start coming to us and saying, okay, this machine has no emissions, no noise, no vibrations. Can I use it in around livestock?
Ah,
Or
okay.
can I use it in the zoo and
Yeah.
not scare the animals in a free range
Cool.
pen?
Yeah.
You know, all those applications that of course you never designed for.
Yeah, just the new
but
crazy things
are
that
perfect applications for this. And that's really where the industry starts to transform and people start bringing in new applications
Yep.
that replace, you know, a man and a shovel
Yeah. Amazing.
with an automated machine.
I wanted to start here because I love batteries and charging.
Yep.
This is the world that our audience is comfortable with. But it makes sense that you literally will have to bring this out to the middle of nowhere.
Yes.
What
So
is this?
This is a portable charger.
Okay.
Okay.
A big one.
Big portable charger, but we deal with large equipment. Our customers deal with large equipment, so we're used to moving this type of thing around.
Yeah.
But this is basically 12 66 kilowatt hour battery packs. So for a total of 792 kilowatt hours of power.
Basically a
on board.
megawatt hour almost in a box.
Almost in a box. Yeah. In our next versions, we've already scoped out how to get these to megawatt and multi-megawatt if you want to stack them together.
Yes, we want to stack them together.
That is the possibility of it.
How do you charge this?
So it's discharged. This one's a charger. So it's
Yeah.
discharged through twin 240 kilowatt level 3 chargers.
Can we show that? So you've got the cables coming off the side here.
Right. So there's one on
wow.
either side.
It literally just comes out the back of the unit.
Yep.
I love it.
So you could pull a machine up to either side of this on your
Yeah.
job site, charge 2 machines at once. Each gun will put out 240.
If this goes missing tonight, don't come after me. This is my dream in a box. This is amazing. So
So charging it, you asked
yeah,
about. Yep.
yeah. So, oh, wow, the doors are easy to move. Holy smokes. Yeah. So here's your other discharge.
So here's your other charger. So
Yeah.
on a job site, this yellow box is what you'd see.
Okay.
Back at your depot where you're going to charge it, you'd have this box.
Oh, so this is the charger for the charger.
This is the power conditioner.
Okay.
So from the grid, you'll get anywhere from 400 volt up. We can handle anywhere from 400 volt to 38,000.
Oh, so you can handle like a mine typically would be 600 volt or something like this. Yeah.
So this box basically takes that in, conditions it, puts it out at 600 volt DC, charges it directly.
And do you just cam lock into this one then?
Exactly.
Okay.
Yeah. So red to red, green to green,
Yeah.
blue to blue.
Could you put like a CCS connection as an inlet on this? Like you could roll up to an Electrify America, leave it for 2 weeks, and pick it up fully charged?
You could.
That'd be funny.
This can take, well, you could do that directly with a machine.
Yeah.
Yeah.
Okay, so that's possible.
So you could pull up a machine to an Electrify America
we
site
have
and
to
plug
do
it
that
in.
for a video. I need to borrow a machine for like a couple days. I just do all the stupid stuff. No one at Volvo watch the videos, please, but we have so many ideas.
So anyway, this is what we call an AC power conditioner.
Okay.
So it takes whatever your AC grid is, or solar field power, whatever power comes into this,
Yeah.
conditions it so it can charge this box, and then we take the box to the job site.
How much does this cost?
This one box can do multiple of these.
Oh, really?
So that's the important point.
Okay.
So you don't carry all your rectifiers and components
Yeah.
out to the job site every day and jostle them around on a truck. You put
Sure.
this in your main spot and charge 2 or 3 of these, or run 2 or 3 of these on a
Yeah,
large
maybe
shop.
every day you just cycle one out or something like that.
Yep, you trade them in as you need to. The other advantage of this is then you don't need a very high power input. So you could plug this in, so what if it takes 10 hours to charge?
Right, yeah.
You know,
Just
you're
sitting
out
there.
in your machine working.
The cost of this stuff is to the end user. I imagine a lot of them go through fleet companies and rental them, but this is not cheap.
No, so like any other battery storage, or when you're talking this amount of lithium ion battery storage, it's a lot of money.
Yeah.
You know,
yeah.
I'm not going to quote a
Okay.
price here, but
Sure.
it's
Yeah,
significant.
Big
Yeah.
dollars for the companies on the leading edge of this
But
stuff.
when you consider, you know, these machines burn 80, 100 gallons of diesel a day, you're starting to replace a lot of that with your operating costs. Now,
So-
we've seen operating costs on these electric machines 70 to 80% lower than the diesel.
That's a
So you
significant
very
difference.
quickly start paying back,
Yeah,
you know, and of course this replaces your diesel infrastructure.
sure. You're
So
still
a
going to have
job
to
site
cycle
that has
diesel in and out.
diesel trucks going in and out, and
Yeah.
having to drive in and refill those, and go to the job sites every night and refill all your machines.
Yeah.
This would replace that infrastructure.
So, okay, we got the charging side of it,
Yep. The high power charging.
the
side
high
of it.
power.
And it would charge something like
There we go. Let's go see some equipment.
this machine, 23-ton excavator, 50,000 pound, roughly. And if you take a look, it's 4 of the exact same batteries we use in here.
And those are Volvo Penta batteries then?
They come from Volvo.
Yeah.
Penta is the one who supplies the independent batteries for the container solution. And UIG is the company that did all the electronics.
Oh, okay.
And we own a stake in UIG.
Ah, very cool.
So, but the same batteries that are used in the machine are used in the pack.
Can I plug this in? Would it blow up if I do
No, go ahead.
that? First time charging. What do you even call the EC230? What type of machine even is?
Battery electric excavator.
Hell yeah. Watch and learn, folks. Yeah, there we go. And we're in. Charging. Now, we don't want to create a trip hazard, so we'll unplug it. But, you know, what I really want for Christmas is the PU750. If anyone's watching.
I'll expect Dave if you're watching.
Yeah, Dad, come on. Amazing. This is really cool. So, about the units that, I mean, you have a line of products, of course, that are going electric. The costs are, of course, higher than the diesel ones.
Yep.
How many years do you measure break even? I mean, how is that calculation even talked about?
So what happens, I was mentioning before, we're seeing 70 to 80% cost of ownership reduction. The machines are more expensive. We're trying to hit 1.5, 1.7 times. Right now, the initial machines are a little higher than that.
Okay.
We're running about 2 times
Okay.
the cost of a diesel.
But that's still not so bad.
No. So if you, again, depending on the amount of use, the amount of hours you put on them, the amount of work you do with them, you pay that back according to the savings on operating costs. Because it's less maintenance, no fuel, you know, all those
So
factors.
you really want to put these in applications where they're out working.
So exactly. I've had people who say, well, they're more expensive. I don't want to put a lot of hours on it and get it, you know, worn out.
Yeah.
It's like, no, you want to do just the opposite.
Exactly.
Put the hours on it. You know, we'll give you the tools to recharge it quickly, get it back to work. But your best payback is if this thing is working as many hours a day as possible.
So I'm noticing hydraulic lines still on the excavator?
Yes.
Is there a future in which everything will become electric motors rather than hydraulic?
There's, again, applications for that. I don't think that'll be throughout the industry just because the electric actuators are not available and are not cheap.
Sure, sure. The supply base hasn't caught up
Right.
to
So
everything.
you go to a fully electric machine in this size, it would be a very, very expensive machine.
Right.
But if you're getting indoor use around food, around something where you can't afford to have a spill, there's a possibility to do that. We've done a fully electric prototype of a small excavator
Wow.
within Volvo. So we had, and Bobcat I know has a fully electric
Yep, exactly.
skid steer.
Yep,
So,
we filmed that one before. Can you walk us through what else you have? So you've got the fully electric excavator. That's sick. What else?
so these are, like I said, the 600 volt high voltage systems. If you go here, we
These are
start
the big boys.
on the 48 volt. So again, the same charging system, so you could pull up to your house charger.
Okay.
It's a J1772 plug, level 1 or level 2. Will charge these perfectly fine. This is a 20 kilowatt system in these small excavators.
Okay.
The small loaders use a 40 kilowatt
Okay.
battery pack.
So you've got a
48 volt, and the reason we use 48 volt, there's a misconception out there that 48 volt is less energy. 48 volt and the 600 volt have the same energy density by weight,
Yeah, of course.
right? It's the charging and discharge speeds that are
But
different.
wouldn't higher voltage just lead to higher efficiency in an application like this? Like, why wouldn't you push it up
The
to...
main reason we do it is because you can get a higher charging speed.
Okay, yeah.
With a 600 volt, power is of course volts times amps.
Yeah,
So with a 600 volt, you need a lot less amperage.
of course, yeah.
Less amperage is less heat.
Yeah. And
So
how
that's-
fast do these charge? These don't DC fast charge.
These do DC fast.
Oh, these do?
Yep.
Okay. But with a different type of connection rather than
Different
a
type
CCS
of
port.
connection. They use a REMA plug. So they have the same J plug connector here
Yep.
and this REMA plug.
Okay,
That's a DC fast charge.
Yep, awesome.
Wow.
Okay.
And how many kilowatts of fast charging can the 48 volt systems do?
So the 48 volts can go up to about 40. This
Oh, wow, that's a
trailer
lot.
that we have here,
So you're like a 1 hour charge time on these roughly.
we're using this trailer, yeah. So we
Awesome.
just developed this trailer, so there are battery electric trailers out there, but they're basically BESS systems.
Yeah.
So what we went and did is took one of those trailers and put a fast charger on it. So that's 130 kilowatt hours of storage,
Yep.
and it discharges with a 40 kilowatt.
Amazing.
charger.
Can we check it out?
Yep.
This is so freaking cool.
So using this, if you had a couple loaders on your site, you can pull up to the loader, you can fully charge a loader in an hour,
Yeah.
an excavator about half an hour.
Amazing.
Using this.
And you can do about 3 0 to 100% charges
Of the loaders.
of
yeah.
the loaders
Yeah.
and 6 of the smaller
5 or
ones.
6 of the small ones.
And you can still hook this up to power in the middle, so you could have a low power connection into this.
Oh yeah.
Yeah. Okay.
You can still, this has all the site drops.
At how many job sites do you imagine they'll be running generators to charge some of this stuff?
Well, what we're trying to promote is if you're going to run a generator, to do it hybrid with a BESS system.
Right.
So it runs much more efficiently as a generator.
it's just
You're running
flat
your
out.
sweet spot. You charge this and then take this out to the machines and charge the machines.
Yeah, that makes sense.
Is
So you
what
have
we're
a J
envisioning.
plug on here as well.
Yeah. So
That's hilarious.
we have a 208, we have a 240,
Yeah.
you have your 120,
Yeah.
and then we have the 2 fast chargers here.
And is there any way that you can do, rather than just the 48 volt disconnection, will you ever have this do high voltage charging, this trailer?
No,
Okay.
no. For 2 reasons. One, this is not set up to do 600 volt. They're lower voltage batteries. The second one is that you drain this in half an hour.
Yeah, of course. Yeah, it's a
and then
small
you're-
battery in this.
Yeah. So compared to what we're running in the
Yeah, I know that big container is so cool, and I can't wait till they're like a megawatt hour in there. It's going to be insane. So, yeah, so you have 2 classes of products.
Yep. So right now we have the 48 volt and the 600 volt. No hurry to go to anything else.
Okay.
But then over about 200, we think about 250 horsepower over about 8-hour duty cycles, 8 to 10 hours. Then you're going to start switching into these other technologies I was talking about.
Yeah.
So it'll be hybrid, it'll
Hydrogen
be grid
or-
connected, it'll be hydrogen, it'll be alternate fuels, it'll be any one of those different.
And that's just what realistically is available today. I mean, you could make anything battery electric today up to a size, but it would just get crazy expensive, crazy heavy.
Exactly, yeah.
And so right now, most of your stuff is using NMC chemistry on the battery packs.
Yes.
Do you think LFP is the future in this space?
We have LFP models as well. Now,
Okay.
right now they're mostly in China and Asia, but we're going to be experimenting with them and seeing the
Yeah.
advantages and disadvantages of both types of chemistries.
Cool.
I'm not going to pick a winner.
Yeah.
I'm not sure yet.
Let
but
the industry decide.
yeah, there are advantages and disadvantages to both chemistries,
Sure.
obviously. So
This has been fascinating, this tour. It's been exciting. If you can't tell, I just love this stuff. It's so cool. And we got to come out and drive some of this stuff sometime. That would be really
we've got to
enjoyable.
ride and drive outside as well.
Let's go. I wish we had time.
L25.
Yeah, that would be so
Loader
cool,
out
the
there.
little tiny
Yeah.
one. Well, I can't thank you enough for the tour. Thanks for all of the knowledge. I hope we get you back on the channel, maybe at a show in the near future.
Yeah,
and we
I'd
can
love
talk
to.
about the progress, how things are going, what your customers are thinking. But to me, this is just, this is like a candy store. This is amazing. So thank you, really.
We're making progress.
Thank you so much. Appreciate it. Well, guys, certainly diesel is going to be king for a long time to come, but I'm actually really excited that Volvo is pushing so hard in the electric space, and these are the hardest things to electrify, maybe just short of aircraft. I'm just so thrilled that these products all exist and they're out in the market. Of course, they have their new VNL that's going to be super efficient from a diesel perspective. I'm actually a huge truck guy. I don't know anything about trucks, but I just love learning about them. So they invited us to the factory so I can take a look at that truck. Probably wouldn't do a video on this channel about it, of course, not a diesel truck, but maybe for my personal channel could be interesting. And then I really want to drive the VNR. They're out there, they're being used. The construction equipment is amazing. This was sick, really cool learning experience. So a huge thanks to the guys at Volvo for being so open with us at their busy show. And hopefully you guys enjoyed it just as much as I did. We'll see you on another one again soon. Bye-bye.